Welcome to video tutorials for SILCS Bio. In this video, we will go over how to run ligand optimization for a parent ligand with SILCS-MC calculations using the graphical user interface. For this tutorial, you will need the directory with SILCS frag maps for your target. You should have generated this using the SILCS simulations module. Additionally, you will need the parent ligand molecule in STF or mol2 file format that you want to modify and optimize. The information discussed in this video is also available on our documentation website docs.silcsbio.com. You can go to SILCS small molecule suite, then go to SILCS-MC ligand optimization, then go to SILCS-MC ligand optimization using the SILCS Bio GUI. Let's start a new SILCS-MC ligand optimization project. You have generated the SILCS frag maps for your target. If not, you will have to get those using the SILCS simulations module before moving forward. Now we will go to the SILCS-MC ligand optimization section on the right side and click on New SILCS-MC optimization project option. Next, we come to the setup page. Here we need to provide some inputs or choose some settings as we did for SILCS simulations. First, we need to give a project name. Second, we have our default remote server auto selected. We can change it if we want from the drop down menu. Next, we provide the SILCS frag map directory location. Navigate to your SILCS frag map directory and just click on the directory icon without entering the directory and click open. This will automatically select the protein PDB file for you. Then we have the option to choose the input file of our parent or reference ligand. It can be either STF or mol2 file. Note that ligand pose must be already situated in a relevant binding pocket as this is an optimization project. The pose could come from experimental data or other docking calculations. There is no advanced settings in this case and we can click setup button. The command execution window comes up and we can see the remote project directory is created. Then the input files are first copied to a local project directory and then uploaded to a remote project directory. When that is complete, we can click the green button, setup successful. Next, we modify our ligand for optimization. On the next page, we can see a summary screen with the project name, remote server, project location, protein PDB file, ligand STF or mol2 file, and ligand modifications. The entry ligand modifications will state 0 modifications saved and have a button labeled Add Ligand Modifications on the right side. Let's press this button to select modifications to the parent ligand. When clicked, the parent ligand will be loaded to the stage along with the protein and the frag maps. Rotate the view until you can see the functional group you wish to modify. Now there are two major modification types, substitution and replacement, available in the GUI. Substitution is used to substitute an atom with functional group. Replacement is used to replace an atom in a ring or aliphatic acyclic group with another functional group that preserves the connectivity and valence of the ring or chain. In the visualization window, let's clean our view a little bit so we can select the atom to be modified. We are going to select this hydrogen atom where we can see unoccupied frag maps around. Then select all small modifications from the substitution tab in the right hand panel and click build modification, which takes us to review panel and takes only a few moments to build the modifications. Valid modifications will have a small image icon as well as small trash can icon. Clicking on the image icon will show the modification in the center panel. Clicking on it again will show the parent ligand. Clicking on the trash can icon will delete the proposed modification from your list. We can go back to the substitution tab and add more modifications to a different R site. Let's select this hydrogen atom where it can lead to unoccupied apolar frag maps with some donor and acceptor maps along the way. We can add moderate substitutions to in this case and maybe some large ones. Let's click build modification button again. You must press save modification button in the review tab to actually save the list of modifications for evaluation by SILCS-MC. We also get a notification saying that it has been saved. Now to go back, click on the SILCS-MC section on the left hand side. The ligand modifications will have been updated to reflect the number of saved modifications that will be evaluated by SILCS-MC. Because SILCS-MC is a fast calculation, it is feasible to select very large number of modifications, probably hundreds, for quick evaluation in a single run. Now in advanced setting, we can check the checkbox for include halogen maps since we have halogen frag maps. The bundle option allows us to reduce the number of jobs in the queue by combining the individual jobs. Here I am going to reduce it to 4. Let's click the run SILCS-MC button now. The jobs are getting submitted and we can click the green button saying setup successful. We can monitor the job progress here on the next page. Since ligand optimization is running the SILCS-MC pose refinement calculations underneath for each modified ligand, it takes just a few seconds per modification. Now let's collect the results and visualize. We can continue to our ligand optimization project with the continue SILCS-MC optimization project option on the home screen. This allows us to do other work while the jobs are running. As you can see, the jobs are finished and a green show chart button has appeared. Clicking that will start collecting the LGFE results. The refined poses of the modified ligands and LGFE data in CSV format are downloaded to the local project directory. Once that is finished, we can click the green button saying data collection finished. On the next page, we can see a new chart tab on the right. It shows a summary of number of favorable and unfavorable modifications associated with a particular modification site. We can click on the name of the modification site to see detailed list of change in LGFE values relative to the parent ligand LGFE for each modification. Now clicking on the name of the modification will display that modified ligand in the central panel. Clicking it again will show the parent ligand. The ligand analysis tab in the right hand panel can be used to reveal the contribution of each scored atom in the ligand to the overall LGFE score. Clicking on the ligand atom in the central panel will display its atomic GFE score and add it to the list of atoms that are used to compute the sum of GFE values for the modified ligand in the right hand panel. The Visualizing Frag Maps tutorial video discusses the use of ligand analysis tab in more details. Let's see how the downloaded files look like. To access the downloaded project files, we can start on the home screen and go to Continue SILCS-MC Optimization Project. Go to our project and click on the Show Project directory on the right. This will open the default file browser for the directory. Here we can see the files related to ligand modifications. Importantly, the lgfe.csv file will have the LGFE and LE data for all the ligands, all the modified ligands and your parent ligand. Additionally, there is a minconf pdb directory that contains the refined poses for all the modified ligands in both STF and PDB format. One can load them in other visualization tools if needed, such as VMT or PyMod. Alright, thanks for watching the tutorial. See you next time.